This video is for homework 8 and this is question 1. In the question 1, first we have to find the expression of yt. However, we know that the xt is white and stationary, so the expression of the xt is one constant. And also we know that the autocorrelation T1 and T2 of x is just related with the tau, which also means that only related with the time. And for the first question A, find the expression of yt. Since we have known that yt equals to the differentiating of the x, so the expression of yt is equal to the expression of differentiating of x, and we can also make the differentiating formula before the expression of x, and since we know that x is the expression of x is a constant, so the differentiating of the expression of x differentiating is 0. And in the second question B, since the xt is white stationary, and we make the time ty equals to ty, which means that which is in the same time, and we get the auto relationship is a constant. It is not related with the time, and so it's easy to get the expression of xt and multiply yt equals to 0. And in the third question, since we get the result from the question B, the expression xt and yt equals to 0. Which means that the expression xt multiplied the expression yt also equals to 0, and therefore the xt and yt are uncorrelated. And since it is uncorrelated, we can easily find that the xt and yt are orthogonal. This is all the calculation in the first question A. And the key in the first question is that we have to just change the equation of the expression xt and yt, and when we do this, we find that the auto relationship in the same time would be expanded with the formula of xt, and since the yt is the differentiating of xt, and the square of xt, the square of xt, and in the outer side it will have a differentiating of the time, which makes one of the xt becomes yt, and that we can find the result. This is the key to solve the question B. That's all. This is all I want to say.